Right now, 3/I Atlas is tearing through our solar system, doubling in brightness every few weeks and building a luminous green cloud 500,000 kilometers across as it barrels toward Mars. Astronomers expected a faint flicker, something barely detectable even with powerful telescopes. Instead, 3/I Atlas now shines 6 times brighter than predictions, confounding observatories around the world and sparking urgent debate over what is really fueling this outburst. Some suspect an unusually active nucleus. Some propose sunlight unlocking strange alien ices buried within, while others wonder if something far stranger is at play. With its closest approach to Mars only weeks away, and Earth's view about to vanish into the sun's glare, the race is on to uncover the truth before this visitor from the stars slips beyond our reach. What is driving this unprecedented display? And what secrets lie inside that shimmering green shroud? At the moment, 3/I Atlas is about 2 astronomical units from the Sun. That is twice the distance between Earth and our star, or roughly 300 million kilometers. Yet despite this immense gulf, its velocity is staggering. It is already traveling at nearly 60 kilometers per second and accelerating steadily. By the time it swings closest to the Sun at the end of October, its speed will peak near 68 kilometers per second. To put that into perspective, that is more than twice the velocity of any planet in our solar system, and fast enough to cross the distance from Earth to the Moon in just over an hour. This is no leisurely wanderer. It is a bullet fired from another star system, cutting through space at breathtaking speed. On the brightness scale used by astronomers, 3/I Atlas has now reached magnitude 12. That number might not mean much at first, but in practical terms, it places the comet well beyond naked eye visibility. Even seasoned backyard observers with years of experience require at least a medium-sized telescope to glimpse it, and only under the darkest skies. The difference between magnitude 6, the threshold of unaided human vision, and magnitude 12 is dramatic. The comet is about 250 times fainter than what the human eye can see. And yet, despite these challenges, 3/I Atlas has been climbing in brightness far faster than anyone anticipated. Something about this visitor refuses to obey the rules. The coma, the vast cloud of gas and dust enveloping the nucleus, has grown explosively. Recent measurements suggest it now spans several 100,000 kilometers, a size rivaling the diameter of Jupiter. This expansion is not merely a visual spectacle. As the coma grows larger, more sunlight is scattered and reflected back toward Earth, making the comet appear brighter even though its solid nucleus remains hidden deep inside. Every major observatory is tracking these numbers carefully, logging new positions and brightness updates into databases in real time, feeding them into trajectory models and alerting the Minor Planet Center of any sudden changes. In September, 3/I Atlas shocked astronomers with a surge in brightness so sharp that its light curve veered dramatically away from all predicted paths. This was no subtle uptick. It was a jolt that set off urgent discussion across both professional and amateur astronomy circles. But the window for Earth-based observation is closing rapidly. Each night, the comet dips lower into the twilight, pressed ever closer to the sun's overwhelming glare. By October 21st, the angle between 3/I Atlas and the sun, what astronomers call solar elongation, will shrink below 30 degrees. That is the point at which even the largest ground-based telescopes struggle to separate a comet's faint glow from the brilliant background of daylight. For most of the world, the practical viewing window has already narrowed to a sliver of time just after sunset, when 3/I Atlas barely clears the horizon before vanishing into haze. Amateur astronomers are scrambling to capture the last usable images, coordinating in global relays to hand off observation duties from one longitude to the next. Meanwhile, online forums fill with a mixture of triumphant successes and frustrated reports of failed attempts. Professional observatories, bound by strict safety limits to avoid damaging delicate optics, are already pulling back. The risk of pointing billion-dollar instruments too close to the sun is simply too high. Once 3/I Atlas passes behind the sun from Earth's perspective, there will be a complete blackout. No spectra, no brightness measurements, no direct images, just silence. The timing could not be worse, because this is precisely when the comet is expected to become most active. The geometry of the solar system itself is closing the door. The only hope for continued monitoring will not come from Earth at all, but from spacecraft orbiting Mars.
For a brief window, Mars will become the best outpost to observe this interstellar visitor. As Earth-based telescopes fade into the sun's glare, the focus shifts to the fleet of orbiters circling the red planet. Each brings unique instruments to bear on the comet. The European Space Agency's Mars Express, with its stereo camera and spectrometer, can capture images and chemical fingerprints from millions of kilometers away. The ExoMars Trace Gas Orbiter, equipped with specialized detectors, is designed to sniff out faint signatures of gases like carbon dioxide, water vapor, and exotic volatiles across the coma. NASA's AVEN, originally built to study the upper atmosphere of Mars, can tune its ultraviolet spectrographer to catch emissions from 3I Atlas's gases, while its plasma instruments monitor how the solar wind interacts with the comet's outflow. Even the Mars Reconnaissance Orbiter, famous for its sharp high-rise camera, may have the potential to resolve the nucleus directly if the geometry and timing cooperate. Tracking a fast-moving comet is always a challenge for spacecraft, but this time the alignment favors Mars. On October 3rd, 3I Atlas sweeps within about 28 million kilometers of the planet, close enough to attempt direct observations, but far enough to avoid the dust hazard protocols that once complicated comet flybys. Mission teams have spent weeks preparing, running simulations, updating trajectory files, and negotiating precious observation slots. Every group wants a piece of this encounter. Visible and infrared images will map the coma, ultraviolet spectra will measure gas production, plasma data will reveal the comet's interaction with the solar wind. Even a handful of successful passes could deliver insights never before achieved for an interstellar object. One of the first things anyone notices about 3I Atlas is its striking green glow. Spectral analysis quickly revealed the culprit, diatomic carbon, or C2. When sunlight strikes these carbon-rich molecules, it kicks them into an excited state. As they relax, they emit vivid green light, especially in the Swan bands, around 510 nanometers. This is a classic signature of active comets, but 3I Atlas stands out for the sheer intensity of its emerald hue, visible even from 2 astronomical units away. Not everyone agrees on the details. Some teams have flagged possible contributions from ionized carbon monoxide or the cyanogen radical, both of which can also glow green or blue under solar ultraviolet light. Early September spectra hinted at these molecules, and debates have broken out in scientific circles over calibration methods and background subtraction. Still, the most robust data sets consistently point to C2 as the main driver. The chemistry here is more than just a visual flourish. Because 3I Atlas is moving so quickly, solar radiation is slamming into fresh ices at an accelerated rate, peeling off volatile molecules and mixing them into the coma. The green light is therefore a direct, real-time indicator of how rapidly the comet's surface is changing as it races inward. A growing number of observers have noticed something even stranger, a faint sunward feature stretching back toward the sun itself, a so-called anti-tail. This runs counter to what most people expect from a comet, where dust is swept away from the sun to form a classic tail. In 3I Atlas's case, the extreme velocity and geometry are conspiring to flip the script. When a comet races through the solar system at such speeds, dust grains ejected from its nucleus can actually move ahead of its path, especially if they are large or electrically charged. From Earth's perspective, this can create the illusion of a slender spike pointing toward the sun. Plasma physicists note that the rapid expansion of the coma combined with the comet's speed creates an environment where electromagnetic forces rival gravity, funneling dust into narrow, sunward streams.
So far, reports remain tentative, with no peer-reviewed images yet published, but the very possibility adds another layer of intrigue to this unpredictable visitor. Every comet that enters our solar system brings its own quirks, but 3I Atlas stands out even among rare company. In 2017, Oumuamua was discovered, a dry, cigar-shaped shard that passed through silently, with no coma or tail at all. 2 years later, in 2019, 2I Borisov arrived, displaying all the hallmarks of a typical comet: a bright blue coma, a dust tail, and a composition dominated by water and cyanide. 3I Atlas, however, fits neither mold. Its coma is not just large, but intensely green. Its surge in brightness, nearly 6-fold above predictions, has no precedent among interstellar objects. And while Borisov's tail streamed neatly away from the Sun, 3I Atlas may carry a faint anti-tail pointing back toward it. Even compared to energetic solar system comets, its behavior is in a class by itself. Eventually, 3I Atlas will round the Sun, brighten briefly, and then fade. Most models predict that its apparent magnitude will decline much faster than it rose, its coma shrinking and dispersing into the dark. For those hoping to catch a glimpse, the requirements will only get steeper. A telescope with at least a 20-centimeter mirror will be the minimum, and even then, only sensitive digital cameras will reveal more than a faint smudge. Visual observers will soon be outpaced by the comet's retreat. Image stacking and careful background subtraction will be essential for any continued tracking. Yet, even as it fades, 3I Atlas will continue to teach. Every brightness measurement, every spectrum, every disputed detection will feed into a broader understanding of interstellar objects. How do comets behave when they travel through a solar system different from the one they were born in? What can their chemistry and dust reveal about the processes that shaped planets across the galaxy? The stakes reach far beyond this single object. Every anomaly in 3I Atlas's behavior is a window into the diversity of small bodies that populate other star systems. After perihelion, 3I Atlas will slip back into the dark, likely vanishing from human instruments altogether. But for now, as it brightens and flares, it remains an open scientific question, an alien messenger carrying secrets from beyond. Unlike Oumuamua's muted passage or Borisov's steady rise, 3I Atlas has arrived in dramatic fashion, demanding attention, rewriting expectations, and reminding us that the universe still holds surprises. Its brilliant green glow, its unpredictable bursts, and its strange dust structures all tell us that not every comet follows the same rules, especially those forged in distant planetary systems. For a brief moment, humanity has the chance to study one of these messengers up close, with instruments on Mars and telescopes on Earth straining to gather every last photon before the Sun blinds us. In time, 3I Atlas will fade and others will follow. But the legacy of this interstellar traveler will endure, in data, in debate, and in the questions it raises about our place in a galaxy filled with worlds and wanderers we have only just begun to discover.